everyone. In today's video, I'm going to be building off of the Biomes mod again, and using the same acid fluid that we created last time to build off of those features. So we'll put those into the world generation, and at the end of the video, I'll also be including this feature into our custom biomes made in a previous tutorial. And you can check out that video in the description below. So yeah, let's just get started. Okay, so we'll start building off of the Biomes mod Java class. And then I created a little comment here called wide lake feature. And so I'll just go into here. So I'm going to create a custom function here. I'm just going to call it VM world gen registers. Register features. And so then I will do this, and I'll add in, we'll do a public static class, the name of that I just created, and then we'll do register features. So within here, we'll do static void, and then we will do an initialize function, but we will have to create that after. So we'll create this VM features dot init. Okay, that's done. Okay, so I created a folder called features, and in it I created all the files that I need to use. So first off, here I called VM features. So Biomes mod features will be here, which I created inside of features. Okay, so within here, we're going to create a public static variable. We're going to create a list, public static list, which is an array, and we'll do a feature array. And then we'll call this features, and then we'll call this new array list. Okay, and then here, I'm just going to create a comment. This will do a public static final feature. And then we'll call a simple block provider configuration. So this is here, and then we will call this wide lake, so we can enumerate that later. And then create feature. Okay, so within this create feature, we will need to create some things. So first of all, we will use a string, and we will call this feature a wide underscore lake. And then we will need to instantiate the codec for this. So we'll call this new wide lake. We'll reference that later. Not wide, wide. There we go. And then we will do the simple block provider config again. Codec stable. Okay, and then under here, we're going to do the initializing of that. So just a public static void init. And we will reference this later when we try to use this wide lake. And for now, this is done. Now we can go back into here and import this. And so then this will be okay. Then I'll go back into my wide lake features inside Biomes mod here. And then from here, we'll add some registry keys. So registry key, and then we're going to be looking for a configured feature. And there are some methods here that we need to reference. And then we'll name this, I guess, just wide water lake, I guess. Yeah, that works. Registry key of, and then we're going to be using a configured feature world gen, and then an identifier. And then we'll reference our mod ID. So I think this one is good. Of. So the registry, first of all, will be capital R registry. And then we will look for configured feature world gen. There we are. And then the value, let's just move this to a new line. I will call this new identifier. And then we'll use a namespace, string, and then a path of the file name. So here, this is the name of the mod ID. So this is biomes like usual. And then in here, we'll just call this wide_lake, wide_water lake. Let's just keep it consistent with this naming here. And there we go. It should be done. Oops, I added an extra question mark there. Okay. Okay, so that's not being used yet, but we will quickly fix that. So we're going to do a biome modification, and we're going to add some features. Let's just use biome modifications, and we will add a feature. Okay, so we got three things here we need to do. We need to add a biome selector, a step, and then a configured feature key, which we've created already. So let's start off with this biome selector. All right, so I suppose we could probably pick a specific one, or we can target all of them, like in the Nether and the Overworld, as well as the End. But in this case, if it's just found in the Overworld, we'll just set that up there. And then we will add in this feature through a mix-in instead. However, feel free to play with this. You can add it to whatever biome you want, like plains or flower forest or whatever. Okay, so now we need to add the step. So the generation step, typically things like ore and biome features is like raw generation, so we'll set that up there. Generation step, feature, raw generation. Let's see what other ones are there. So there's lakes, local modification. Yeah. Okay, so raw generation is okay. And then we will reference this wide water lake that we created earlier. There we go, that'll fix that. Okay, so we're gonna get a couple big ticket items out of the way before we move on to the really heavy coding. So first I created a couple files here, BM configured features and then BM default biome features inside of the features folder here. So we'll just get started on that. Okay, so for BM configured features, I'll add public static final, and I'll add a configured feature. And it's the same thing again where add that. And we'll call this wide water lake. And then we'll create a configured feature. And then we'll create three things here. So we'll create a string. So we'll just do a wide water lake, add a new line. And then here we'll reference biome features. And then we'll reference this wide lake. Then we will set up a new configuration for this. So we'll do new simple block provider. Then the block provider, we'll create a new block provider. So we'll create new simple block state provider. And then the block state that we'll want to copy is water. So I think we'll just do blocks. Yeah. And then water. And then we'll get the default state. And here, we'll just create a new line. Then we're going to use a decorate. And then create a new decorator here. But first, we'll just set up this decorator. And we'll set up a water lake. And then the configure. Let's see. We'll set the chance for this to spawn in the world. So this, call this chance decorator config, and then this, we'll set it to 100%, so it'll always generate. Next, then we'll do the biomes mod default biome features, which is just BM for short. And then we'll create here the public static void, and then we'll add a large lake. So we'll just call that add large lake. Simple enough. Then inside of here, we'll create a generation setting builder. So just like so, and then we'll call this gen. So it's simple to reference. So gen. And then feature, and we'll use two different things here. We'll use raw generation and the configured feature that we set up earlier. So the feature step here will be generation step feature, and this is raw generation. A new line here, and then the feature will be referencing BM configured features, and we'll use that wide water lake. Okay, that's done. Okay, next is the WorldGen registration helper. So again, it's in the same folder as all the rest of the stuff here. Okay, in this file, the WorldGen registration helper, we'll create two things. We'll create a feature, and then we'll create a configured feature built off of that. So first, it'll be public static. I'll reference, see, extends feature config. And then F extends a feature. And this will be C. F create feature. This will be string ID, and this will be F feature. Okay, so we'll do an identifier. Call this BM ID, new identifier. And then we'll reference the namespace and the path. And so this will be biomes mod ID. Of course, up until now we've just been doing biomes, but I actually created a constant here for that. Okay, next the path will just be ID here. And we'll create an if statement. If registry feature, and we'll have to get IDs. And then it contains BMID. We'll throw a new illegal exception. Illegal state exception. That's good. And then we'll call this feature ID. Then we'll reference the biome ID here. And we'll just set this to string. Then we'll set what it's doing. So this already exists in registry. And then here we'll set a registry register. And here we will register the feature. The ID is just BMID. And then the entry is feature. And then we'll reference BM features, feature add, and then feature. And what else do we need to do? In order to complete this, we'll have to set up a return statement. So we'll set up return feature. And that will fix that. Go. Okay, that's done. So next line here, create another public static. And then this will be a feature config. So this will be FC, and then extends feature config, and F extends feature. This will be FC, and we'll call this CF extends configured feature. And we will reference FC and F. Then the configured feature here, we'll create a create configured feature. Not done yet. We'll do the same thing we did up top. We'll set a string ID, and then we'll set, oops, OS ID. There we go. And then we'll set CF configured feature. And then we'll set this identifier. Call this BM ID again, and then a new identifier. And then we'll actually just copy this because it's the exact same. And then we will create another if statement But here it will be a built-in registries, a configured feature, and we'll get the ID, and if it contains BMID, then we will throw a legal state exception. So we'll copy that line, and then we'll call this configured feature ID. String already exists in the registry. Okay, that's good. Okay, next we'll do the registry feature again. So registry, register, and the built-in registries configured feature again. And then this will be the VM ID that we set up there. And then this will be a configured feature set in here. We'll paste that in there. And then we'll add the return statement. And that will close all that off. Perfect. Okay, so that's good. Okay, so the big titanic task here that we need to do is we need to create our own feature. So what I have done here is I created a file called wide lake, and I extended a feature, and we created a couple things here. So this is auto-generated constructors, but we will dive into these further. So first thing we're going to do is going to create some constants. So in this file, we'll just call this protected static final, and then we'll set material, and then we'll call this unacceptable solid materials. And these will be immutable sets of, and then we'll create a list of material. So the first material that we'll set up is material dot, and then we'll just go down the list. So I'm just going to add in all of these different ones that are by default to me that makes sense. So feel free to pause the video and copy these down. And then our next one will be another protected line, long, and then we'll call this noise seed. We'll reference this later. And then another protected. I'm going to create an octave simplex noise sampler, and this is just the noise gen and the world gen, so we'll call this noise gen. And then we'll put this seed to use, so we'll call this public void set seed. Create a new function here, and then we'll reference long seed. Then we'll call this chunk random, and then a shared random seed. This will just be a new random chunk random, and then we'll reference seed in this function. Then we have to do something with this shared random seed. So we'll create an if statement. Oops. Okay, so in this if statement, we'll reference this noise seed does not equal seed, or this noise gen equals null. Then we'll set this noise gen equals new octave simplex noise sampler. And we'll have to do something with this. So we will figure this out here. We'll reference shared random seed. And then we will use an immutable list of 0. And then in order to complete this line, we'll say this noise seed equals seed. Okay, so in here, public wide lake. Okay, this is all automatically generated. So with this line, I'll just change this to config factory, and then I'll save that. Okay. Okay, next is the generate block that we created. So override is okay. It's a Boolean generate. So structure world access world is okay. Chunk generator. We'll just call this chunk settings. Random is okay. Block position. Instead of POS, we'll just call this position. And simple block provider config is okay as well. All right, we're going to delete this line. Okay, so first then, we will reference set seed. We will get the world seed. So world get seed. We'll get the block position. So block POS is mutable. New block POS mutable. And then we will set position. Let's see. Up, down, left, right. Let's say, let's go down, and let's go down 2 blocks. Okay, and then we'll create a comment here, creates the lakes. We'll add the bit of code here that creates the lakes. First, we need to create a few things here. So we'll create a Boolean, and then we'll call this contained flag. Then we'll create a material. Just call this material. Then we'll create a block state. Then we'll create a for loop. And we'll iterate through this for loop, and I think 2 blocks is okay. Okay, so first of all here, we'll create the shape. So we'll create an int x equals -2, and x is less than 18. We will keep going through x until it's finished. Then we'll create another for loop in here. And then we'll use z. And we'll do -2 again. Z is less than 18 again. And then we will go through z until we're finished. Okay, and then we'll create a few temporary shapes. First, we'll use int xtemp equals x minus 10, int ztemp equals z minus, and we'll create a circle shape. So we'll have to create an if statement. So we will x temporary and times that by itself, then plus ztemp times that by itself. And if that is less than 64, then we will return. So within this logic, we'll have to create some shapes here. So next, we'll do a double sample. Just call this Perlin1. This noise gem sample. Okay, let's see. So this x will be a position, get x, plus x times a float, so 0.05 d, and then this will be position, get z, this will be plus z times 0.05 d. And if we're going to use the origin, I guess so. Yeah, true. And we'll plus that by 1. And we will times this by 3.0 d. Okay, so we're going to have to create another for loop. This will be an integer, and then we'll set this to y equals 0. And then y is greater than the negative of sample Perlin. And then iterate down of y until finished. And within here, we'd have to create a bunch of logic here. So we will do immutable set. And this will be position. Now we'll have to move this. So we'll set this to x, y, and z. Then I'll create a comment. I'm going to call this check if the spot is solid around. Nothing solid above. So this will be where we'll use our contained flag and check if a valid spot. We'll create that function. But for now, we'll just use this and then mutable. And we'll use that sample Perlin again. Okay, so next, if we're gonna check is in the mask, so it is spot within and contained. An if statement. This if will be in the contained flag. Okay, block state, config state. Config.get block provider .get block state, and then random, and then the POS is just mutable, and then world set block state. This is mutable again. This is config state, and then the flags. We'll just set this to 3. Another if statement. And let's see here. Okay, set this to config state. And if config state is blocks.water, I have to get the default state. World.getFluidTick scheduler, schedule, mutable. And then I'll have to reference fluids, and water, and then delay is 0. And else if we have to do this for lava as well. So if config state is blocks lava get default state, we'll copy this line, and fluids is lava. Next is we'll remove floating plants from hovering. And this is check above. And then we'll use block state equals world get block state, and this is mutable. And then we'll have to move a direction. So first direction, I guess we'll go like we said we were going to, is up. And then the material is the block state, and then get material. And I have to create an if statement here to deal with all of the plants and whatnot. So let's see here. Let's see, material is plant and block state get block does not equal blocks. This will be a lily pad. So if it finds a lily pad, it won't destroy it. Yeah, okay. So then what we'll do is here we'll set world set block state. Again, this is mutable. By now you can probably see a pattern in all of this. And then we'll set the block to air. and then we'll get the default state of that air, and then we will set this to 2. And I'm not quite done here with this, so we're going to recursively move up and break floating sugarcane. And so create a while loop. And then mutable get y location is less than world get height. And world get block state. This is the mutable. We have to move in a direction, so we will pick direction up. And then we will pick the blocks, which will be our sugarcane, and get default state. And this is world set block state, mutable, and the state will be block air again. Get default state, and then the flag will be 2. I guess I could have just copied that line just for quicker, I guess. It's okay. Okay, so we're done with the if statement. Then we'll create another if. And so in this if statement, we are going to check if it's vines. So if material equals any material which is a replaceable plant, above ground plant, and is a block state, you get the block, and it does not equal blocks vine, then we copy that line so it's quicker. We will set that to air, and then we will also go up. So up. All right. So next thing we need to do is we'll have to set up another while loop. So what we're going to do is we're just going to copy this. And then it won't be that, but instead it'll be recursively moved down and replace water with acid. Okay, so then we're going to change a few things here. So instead of moving up, we're going to move down. And then instead of block sugarcane, we'll do block water. And then instead of air, we will set this to our biomes mod, which is ID, and we'll set this to acid, and we'll get the default state. And we have to get a fluid tick scheduler as well. So we'll copy this up here, and then we'll paste that in there. And here, we will reference biomes mod again, and then we will reference our still acid. Fix this, and then we'll return true. Okay, so now we need to create this function. So underneath here, we're going to create a private boolean check if valid spot, and then we will add in some of these, and then I'm sure we're going to have to return okay, so we're going to create a material. Oops. And then we're going to create a block state. I'll create a comment here. Cannot be under ledge. So all of this logic is going to be if it's in a valid spot. So it's going to make sure that it has certain rules in place, otherwise it won't generate properly. So first logic here will be our block position, and it will be mutable, and then we'll just create a temp new block position mutable, and then we'll set block POS mutable. Okay. And then we will reference block state, world get block state. This will be temp. We're going to go up. And then we'll create a while loop. And so we're going to check if it's not this block state, get fluid state. Make sure it is not empty. And temp, which is the block position, and then it has to be below 255 on the y-axis. So get y. Okay, and then we'll move direction up. Okay. And then we'll create an if statement here. If not, if not, block state is air, and block state get fluid state is empty. Return false. Okay, so next rule, it must be solid below. It will return false if unacceptable solid material found. So we'll set those here. Okay, so it's block state equals world get block state, and this will be this block POS mutable. And then We're going to go down this time. And then material equals get. It's actually just block state, and then it's get material. Then we have to create an if statement. In brackets here, I will create if not. So if material is not solid, or unacceptable solid materials contains material, or block tags is planks has to contain block state, so contains block state, get block, and then block state, get fluid state is empty, as well as get block state, get fluid state does not equal fluids, water, it's still, close that off, false. Perfect. Okay. Next, we're going to place water on the tip. So we'll have to create another if statement. So we'll reference noise is less than 2 double, and it will be world dot get block state and that will be this block mutable up is air. Yeah, there we go. Okay, so we'll create an int and we'll create a for loop. And so for the direction, and then direction type will be horizontal. So material, we'll create a material, and then we'll get the block state, and then we'll offset that. So we get block state, that block POS mutable again, and then offset this, and so the direction. Get material. Okay, and then we'll create 2 if statements here. First one is we will check if unacceptable solid materials contains material 2. will return false. And then if world in get block state, block position mutable, offset, that will be that direction again. Direction is air, and then we'll open we missed a bracket there. And one more, if open equals 1, return true. Perfect. Okay, last block here must be solid all around and will return false if unacceptable material okay. Create a for loop, and then inside that for loop we'll create another for loop. Okay, so an integer, we'll call this x2, and then we will start at -1. x2 has to be less than 2, and then x2 will iterate up. Then we'll create another int, and this will be z2 equals -1, z2 less than 2, and then z2 iterate up again. Then in here the logic will be block state equals world get block state, and that will be that block POS mutable. And then we'll add in x2, 0, and z2. And then this material, we'll get the block state material. And then another if statement. We'll actually copy this line here. So if material is not solid, or unacceptable materials find contains material, or block tags is planks contains block state get block, and is empty, and get fluid state is not equal water get still, false, return false. Perfect. That's exactly what we need. Okay, and then we'll change that to return true. And that monstrosity is now done. So if you've made it this far, congratulations. If you haven't fallen asleep yet. Next thing that we need to do, it's not quite over yet, is we need to set the biome features. So what we'll do is we will create this biome features mix in, put it in the mix in folder, and then within this here, the biomes.mixin.json, I added that into the client side reference so that it knows where it is and it knows what to load. Okay, so let's see. We're going to do an inject method. So at inject, we'll call method, and then we'll do some funky text here. Feel free to copy this. And then at equals at, and then we'll have to do on the tail. So tail, and then we'll create private static void add planes features. And this will be generation settings, builder, and then we'll just call that builder, and then call back info, and then we'll call this CI. And then here, we're gonna set a builder feature. So our first feature step will be a generation step. Feature and generation raw, so raw generation. And then the feature will be BM, so biome mod configured features. And then we will reference our wide water lake that we created. Okay. That should be all done and good. Now, once you finish this, all of the errors and stuff should go away, and all of the references should be good, and you can go ahead and start testing. So just click on Start Debugging, and yeah, works just as you expect. And so these will generate all over the plains biomes. Of course, there's other biomes that you can set this up as, but yeah, that's up to you to figure out from there. If you have any questions, you can go and join my Discord, and then I can help you out from there. But other than that, yeah, this is it. Okay, and one last thing I said I would do is add it to the custom land that we had created before, so the custom biome. In your biomes mod Java file, we created a biome field here. And under this function, everything will be here, and you'll see that you can add different features to the generation settings. So what I did is I referenced these biome mod default biome features, which is right here. I referenced it and I added the large lake, and then in here I set it to the generation settings. And so what you can do is you can actually create more of these features and then just add them to each biome if you make them. Here I just created a comment, just says add feature to custom biome. So that's how you do that. Awesome. Well, thanks for watching. Sorry that was such a long video. I mean, some of the code was pretty bulky. But yeah, if you watched it all the way through, congrats. And yeah, stay tuned for new videos coming. To get notifications when my new videos are out, hit that notification bell down below. And if you guys found this video helpful, make sure to give me a thumbs up. And if you haven't already subscribed, consider doing so. And leave any video requests down below in the comments section. And yeah, that's it for today's video. So thanks so much for watching.